Good morning, my dear students. Welcome to my physics class. Our today's topic is inertia and concept of force. Let's start now. At first, we'll learn Newton's first law of motion because in our previous chapter already we have learned distance, displacement, speed, velocity, acceleration, retardation, and we have deduced the equations of motions, and this equation is these equations are used to solve mathematical problem related to motion. In this lesson we will learn how the motion is affected by force and how motion is created by the force. So before understanding force and inertia, we will learn Newton's first law of motion. A stationary object will remain stationary, and an object in uniform motion will continue its uniform motion unless a force is applied to it. This is the statement of Newton's first law of motion, and from this law we can understand that a stationary object will remain at its rest position unless an external force is applied on it. And in the second part, the object which is in uniform motion will continue its motion unless an external force is applied on it. The first one is very easy, and we know if the object is at rest position, the object will remain at rest position unless we apply force on it. So the stationary object will remain stationary unless an external force is applied on it. But we know if we apply force on a body and if the object start to move, and after some time the object will stop and it will be at rest position. But according to Newton's first law of motion, the object which is in uniform motion will continue its motion. So to continue the motion of a body, we need to apply force on it in practice. But according to Newton's law, we don't need to apply force on a moving body which is in uniform motion to continue its motion. The object will loses its motion because a resistive force acts on it. This force may be friction or air friction. If there is no frictional force or any other force which resists the motion of the body, then the body which is in uniform motion will continue its motion. So from Newton's first law of motion, we can understand that the body which is at rest will continue its rest position, and the body which is in uniform motion will continue its uniform motion. Here the ball is at rest position. When the force is applied on it, then it start to move, otherwise it will be at rest position. And here if we apply force, when the force is applied on this cradle, then the cradle is start to move, otherwise it is at rest position. And here this ball is in uniform motion. If we don't apply force on it, then it will continue its motion. From Newton's first law of motion, we get two important concepts. Number 1 inertia and number 2 force. First, inertia. From Newton's first law of motion, we know if you don't apply force on a body, then rest body will remain its at rest position and the moving body will continue its motion. And inertia is the property of the matter. Every matter tends to retain its state of rest or motion. This property of the material is called inertia. We know rest body will be at rest position and moving body will continue its motion unless an external force is applied on it, and this property of the matter is inertia. Every matter tends to retain its state of rest or motion. This property of the matter is called inertia. So from Newton's first law of motion we get the concept of inertia. Place a card on a glass and place a metal coin on the card. Now flip this card suddenly. You will see that the coin falls into the glass because this is the inertia. Due to this inertia, the coin is at rest position. Suddenly the card is in motion, but the coin is at rest position. Due to its rest position, the coin falls into the glass. And here passenger lean forward when the bus stopped suddenly, because when the bus is in motion, everything inside the bus is in motion. So passengers and bus are in motion. When the bus stopped suddenly, then the lower part of the passenger attached with the bus is at rest position with the bus, but the upper part of the passenger is still in motion, and due to this motion the passenger lean forward, and this happens due to the inertia of motion. In this case, passengers lean backward when the bus starts to move suddenly, because when the bus is at rest position, the passengers are at rest position. When the bus starts to move, then the lower part of the passenger is in motion, but the upper part of the passengers is at rest position. So due to the inertia of rest, the passengers lean backward. These are the example of inertia. Now we will explain these two graphs. Here position versus time graph and here velocity versus time graph. These two graphs are identical, but from these two graphs we will get different informations. These two graphs are identical, but we will get different informations from these two graphs. At first, position versus time graph. In this x-axis time and in y-axis position. Here 0, t1, t2 time, and from 0 to t1 it's a straight line parallel to the x-axis. That means there is no change in position up to t1 time. That is 0 to t1 time there is no change in position. And from t1 to t2 the position of the object is changed with time, and this is a straight line, so position is proportionally changed with time, so it is uniform velocity. and from T2 the object is at rest position because there is no change in position in this portion. So only from T1 time to T2 time there is change in position. Here there is no change in position, so 0 to T1 there is no force, and from T1 to T2 it is uniform velocity. So in case of uniform velocity there is no applied force, and from T2 there is no change in position, so there is no force. But at T1 time the force is applied for a moment and the rest body start to move, and at T2 time force is applied to stop the body. So force is applied at T is equal to T1 time and force is applied at T is equal to T2 time. These two time, that is at T1 time and at T2 time, force is applied only, otherwise there is no force. But here velocity versus time graph, 0 to T1 there is no change in velocity, so there is no change in velocity, there is no force, and from T1 to T2 time there is change in velocity. This is not uniform velocity. If you want to change the velocity we have to apply force. So from T1 time to T2 time there is force, that is applied force act from T1 to T2 time, starting at T1 time and ending at T2 time. From T1 to T2 time there is applied force, and after T2 time there is no force. But in this case at T1 time there is force and after T1 time there is no force, and at T2 time there is force and after T2 time there is no force, and 0 to T1 time there is no force. Here 0 to T1 time there is no force because there is no change in velocity, it is uniform velocity. So in case of uniform velocity there is no change in force. But from T1 to T2 time there is applied force. Now what is force? Force is that quantity the application of which a stationary object starts to move and a body moving with uniform velocity changes its velocity. That means if you want to move a rest body then we have to apply something on it, and if we want to change the velocity of a body we have to apply something on that body. This something is the force, that is something external, something or external causes which changes or tends to change the state of rest or state of motion is the force. So force is that quantity the application of which a stationary object start to move and a body moving with uniform velocity changes its velocity. And here when the force is applied on this box then the box tends to move or start to move. So force is push or pull. Now nature of force. There are four fundamental forces in nature. Number one, gravitational force, electromagnetic force, weak nuclear force, and strong nuclear force. Only these four fundamental forces are in nature. Gravitational force. We know everything in this universe attract each other with a force. This force is gravitational force, and this force acts for due to their masses. All the objects in the universe attract one another by a force due to their masses. This force is called the gravitational force. We know gravitational force depends on masses of the objects and distance between them. This is the solar system. The planets revolve around the sun due to the gravitational force. Now, electromagnetic force. The electromagnetic force is the combination of electric force and magnetic force. It acts between charged particles. We know the charge of same nature repel each other and charge of opposite nature attract each other. Positive charge and negative charge attract each other. Two positive charges repel each other and two negative charges repel each other. This is the electric force. And we know north pole of a magnet attracts the south pole of another magnet, and north pole of a magnet repel the north pole of another magnet. This is the magnetic force. That is, there is a force between two magnets. This force is magnetic force. And electromagnetic force is the combination of electric force and magnetic force. Electric force and magnetic force are two different forms of electromagnetic force. Here positive and negative charge attract each other, positive charge repel each other, and negative charge repel each other. And here north pole and south pole of magnet attract each other, but north pole and north pole repel each other. And due to this electromagnetic force, the atom is formed. That is, electromagnetic force is responsible for the formation of atom. And due to this electromagnetic force, the electron revolve around the nucleus. Now, weak nuclear force. Weak nuclear force is weaker than electromagnetic force but stronger than gravitational force. You know, electromagnetic force is stronger than gravitational force. Weak nuclear force is weaker than electromagnetic force, but it is stronger than gravitational force. This force is responsible for radioactive decay. That is, the emission of electron or beta particle from the nucleus is due to this weak nuclear force. Here, due to this weak nuclear force, the proton is converted into neutron. Here, beta decay, that is emission of electron from this carbon 14 isotope, and here emission of positron from this carbon 10 isotope. There is excess, if there is excess number of proton or excess number of neutron inside the nucleus, then the excess proton or excess neutron is converted into neutron or proton. That is, proton is converted into neutron or neutron is converted into proton if there is excess number of neutron or if there is excess number of proton. So, electron or positron can be emitted from the nucleus. This emission of electron or positron from the nucleus is known as beta decay, and weak nuclear force is responsible for the beta decay. Now, strong nuclear force. The force between the nucleon, the common name of proton and neutron inside the nucleus is nucleon. That is, by nucleon we mean proton or neutron. The common name of proton and neutron is nucleon. The force between the nucleon inside the nucleus of atom is strong nuclear force. This force is responsible for the formation of nucleus of atom. We know inside the nucleus there are protons and neutrons. Protons are positively charged, but neutron is chargeless particle. So inside the nucleus there should have repulsion between protons as they are positively charged, but to form the nucleus they should attract each other. This strong nuclear force is responsible for the formation of nucleus, that is nucleon attracts each other with this strong nuclear force, so nucleus is formed. Here atom, inside this atom there is nucleus, and nucleus is found by proton and neutron. Proton is positively charged and neutron is neutral, and there is strong nuclear force between nucleons, that is between proton and proton, between proton neutron, between neutron and neutron there is strong nuclear force.